In 1910, a new way of travelling became a mass phenomenon. The conveyor belt revolutionised the production of cars and made them affordable to more and more people. Driving a car, that means the freedom to go anywhere, anytime. To take your family, your luggage and your shopping with you, to be more comfortable. The big issue today? It's congested roads. There are more than 250 million cars on the roads of Europe and growing.
We're expecting an increase in 50% by 2025, and that means additional pressure on the road network, and as you know, there's only limited capacity.
Today we rely on loops in the road, we rely on radar detectors or traffic cameras, but this only gives us a very partial view of what's really going on in the roads.
It's time to find a solution. That's why in 2004, a group of specialists in intelligent transport systems came together who shared a vision. We imagined a future where cars, vehicles and road infrastructure would communicate with each other to create and share radically new kinds of traffic and travel information. We believed this cooperative mobility could make every journey safer, quicker and greener.
My vision for the future is a fully interconnected world.
Cooperative systems are the next big thing in the traffic world.
Research during the last 5 years has brought us to the threshold of Mobility 2.0. This means connected mobility. Your car in the future will be able to talk with other cars and with the roadside. The innovative technologies to make this possible are called Cooperative Vehicle Infrastructure Systems, or CVIS for short. Let's look at some examples developed in the European research project with the same name. Imagine that the information from fixed and dynamic road signs could be delivered to your car's dashboard at just the time and place you need it most. Suppose you could receive warning of hazards beyond your view sent by vehicles up to 1 kilometre away. You will trust your navigation system more, knowing its recommended route was calculated taking actual traffic conditions into account. When you're driving in the city, you'll get routing advice from the traffic management system to guide you to a free parking space. You save time and fuel and spend less time in traffic jams. The car is always connected through the internet. There is a constant exchange of information over a wide range of carriers, including cellular, mobile Wi-Fi, infrared or short-range microwave channels. But communication is not everything. Precise positioning is also essential for cooperative applications, so CVIS has developed a solution that combines satellite with wireless network positioning and can deliver real-time lane-level positioning when combined with dynamic digital maps. Cooperative technologies work by collecting location-related data from vehicles which could compromise a driver's right to personal data privacy. David Martin Clark, a lawyer at Thomas Miller in London, is an expert for questions about data privacy.
Well, there are a number of techniques which have been evolved, are evolving. They're called PETs, privacy enhancing techniques. Things like encryption, anonymization or pseudonymation. I would certainly say that from a legal point of view, CVIS is doable.
Engineers need to keep in mind these privacy issues at all times when they're designing cooperative mobility applications. They need to integrate and guarantee the anonymity of individual data as a crucial element for every cooperative mobility application. The CVIS project has defined an open application environment. But what does that mean in practice? During a journey, the moment a new service becomes available, a notification will pop up to inform the driver, who can choose to use it or pay for it. In the future, there will be a cooperative mobility app store in the vehicle, just like in today's smartphones. The technological challenges are huge, but more important, cooperation is needed from all stakeholders. This is why in 2006, 62 partners, including top vehicle manufacturers, suppliers, road and telecom operators, universities, researchers and public administrations came together in the CVIS project to turn their cooperative vision into reality. thanks to co-funding from the European Commission DG Information Society and Media. We are now proud to present our achievements publicly and start deployment. All of us in the CVIS consortium are impatient to see our results out on the road and generating benefits for transport users and operators.
We are creating the raw materials, the building blocks for a future world where your car, trucks, buses, anything that moves, even pedestrians, can be connected with other moving vehicles, entities, or with the infrastructure.
In CVIS, we've tried out over 10 separate cooperative mobility applications, and the results are very promising, meaning for travellers safer and more comfortable journeys, less time spent in traffic jams and lower fuel costs, while operators have new tools to manage their road network in a more cost-effective and eco-friendly way. London is the biggest metropolis in the European Union, with over 7 million inhabitants. In a city so dense, freight transport is a great challenge. The road network is already at the limit of its capacity. A CVIS trial has explored how deliveries could be made more efficiently in the future using communications.
We have a challenge in London to meet future demands on the road network. Traffic is going to be a problem, and rising traffic volumes will be. Cooperative systems might be one of the solutions, and this is why we're working on the project. Our test site involves real freight operators, which is the only test site in Europe which does that.
Right, that's all booked for you, mate.
Freight operators can pre-book a loading bay on one of London's busiest streets. This brings a lot of advantages.
The main advantage of the system that we've trialled is that the loading bay is empty when we get there. We can deliver to the customer without the fear of blocking the road, parking tickets, things like that.
There are some companies, the larger ones, who can get up to £1 million per year in penalty charge notices.
If a non-CVIS vehicle approaches the loading bay and it arrives within 10 minutes of a CVIS booking, the infrared unit will detect it. A text message is generated and sent to the enforcement officers. The officers then arrive as quickly as possible and ask the vehicle driver to move on from the bay.
We have chosen Earls Court Road because we wanted a central London location where the pressure is considerably on freight operations and on freight loading.
I saved quite a lot of time because normally before the system was installed it would take me 10 to 15 minutes once finding a bay and parking, but now the system's been installed it helps me a lot because it's clear and I'm in and out the shop, so it's a really good system.
Local authorities already use sophisticated traffic management strategies to fight congestion, but CVIS could be a useful tool to improve their effectiveness. Priority lanes help buses to bypass stationary traffic and keep to time, but they also reduce the road capacity for other traffic. With CVIS, a dedicated bus lane can be used by both authorised and CVIS-equipped vehicles travelling in the same direction, allowing them to use the lane when no bus is present. And bus speed, punctuality and economy would not be compromised. Another cooperative solution for local authorities is to use vehicle communication to optimise traffic light timings by adjusting for individual vehicle movements and destination, while sending drivers the recommended speed to get through on green.
This room is the Traffic Operations Center. Our colleagues over here can monitor and control the traffic lights of the Turin city. The benefits that we expect from the CVIS is to use the equipment and the data that are going to be provided. We expect basically to improve the monitor of the traffic and having the enablers to provide added value services and location-based services.
Cooperative systems are not just a promising technology. They can also deliver real economic benefits.
What is certain is that the costs for the infrastructure operator of collecting data can be reduced dramatically, while the information produced can be of much higher quality.
There is still work to do before cooperative systems can be really deployed. Most important, the system has to work in all countries and towns across Europe, and in all types of vehicle. Secondly, the public needs to know about the kinds of products that will come out of this research, and of course, their benefits for daily life.
I believe we have to convince to make it happen all the responsible people to tell them which huge benefit could be achieved by the cooperative systems to improve their infrastructure components.
The most important is that we have the real customers will actually buy these services, that we have a real pickup from the end user. Then we know that we have done the right thing.
We did several user acceptance tests, and it appeared that the audience really is looking forward to have CVIS applications in their own vehicles implemented.
Field operational tests can help us have more detailed information about how the users perceive those concrete applications.
A car can drive from the Netherlands to Germany to Italy using the same application like parking, like tolling and so on, in the same environment. And that's what the field operation test in the coming years will have to work on, and will prove that cooperative systems is something to stay.
The promising results of the CVIS project have motivated the consortium partners to work together after the end of the project in an alliance to exploit and promote their results. The CVIS technologies together represent an open platform suitable for almost all foreseeable future cooperative mobility services. The alliance will be the repository of CVIS results and knowledge, and the home for future collaboration amongst the many stakeholder groups needed for deployment.
The Open Platform Alliance is one of the prerequisites for the next big stage of ITS and cooperative systems. We are starting this in 2010, and I would say that it's very essential even that all the interested parties get involved in this, both from a technical perspective, but also from a commercial, legal perspective. We are going to grow this, and in order to be part of this cooperative systems alliance idea, please do get involved as soon as possible.
One day soon we hope to see this kind of equipment in every vehicle and also in every important location on the roadside, so that the vehicle can communicate and provide information, receive information, and all kinds of services that we cannot even imagine can begin to blossom around the roads of Europe.